direct equivalent to your t-test, Mann Whitney u-test. Okay, we will go to that, and that is, as I said, it works on the ranks. It takes rank data. That means you can use ordinal scale for this. Ordinal scale can be used, right? Ordinal and above. That means above scales can always be used. Don't worry about when you apply non-parametric. Above scales can always be used. That means interval scale and ratio scale can always be used for non-parametric. But you cannot use ordinal and below for parametric scales. So that is the change. So let us go for Mann Whitney u-test. We will be using the same data that is there. Same data will be used, and we will apply Mann Whitney u-test. Right? And on what values are we going to apply Mann Whitney u-test? We can apply it on the amount spent on haircut and gender. We can use gender as the classifying variable and amount spent on haircut as the dependent variable, and apply Mann Whitney u-test on that. The only problem will be there is some missing data that we will treat. Okay, go to analyze, go to non-parametric, go to legacy, and go to 2 independent samples. Just like t-test for independent samples, it will be applied. So 2 independent samples. You find that there are 4 options underneath. Okay, look at the bottom. There are 4 options: Mann Whitney u-test, Kolmogorov-Smirnov Z, Moses extreme reactions, and Gwalior runs test. Okay, Gwalior runs test, Kolmogorov-Smirnov Z, and Mann Whitney u-test. See, Kolmogorov-Smirnov Z is more suitable to the data which has common ranks. Okay, if there are number of respondents who have given the same rank, then Kolmogorov-Smirnov is a better test because it discriminates, it divides common ranks into different ranks. So therefore, Kolmogorov-Smirnov we will apply where there are large number of common ranks given. In our case, hardly any common ranks are there, so we can apply Mann Whitney u-test. Right, so Mann Whitney u-test test variable will be haircut. Hours, height, current, distance to be. नहीं है प्राइस पेड for last is haircut ना price all right, price paid for last haircut हो गए, and so you have selected Mann Whitney u-test. We have the dependent variable, test variable. We need grouping variable also. Grouping variable will be female dummy coding, that is male female, 0 for female and 1 for male. 0 and 1. 0 and 1 are the codes that are used for male female. So we will do that. Options. Now here we will put exclude cases listwise. Okay, exclude cases listwise. Okay, because here we are going to remove some of the respondents, and I will show you that it does. Okay. Now look at this. And female 1 to 1, male 1 to 1, female is 93, total 214. Okay. Out of that, the ones who may not have responded have been removed already. Now the result is the value of Z. See, there are 2 test statistics calculated in this. Mann Whitney U. That means U would be calculated and that is converted into Z. Okay, the two statistics are computed. You can interpret the Z, you don't have to interpret the U. Look at the bottom one. The value of Z is 9.42482, indicating that the Z value is 9.482, significant at 0% level of significance. That means this value is significant. That means difference between the price paid for last haircut between male and female respondents is significantly different. Okay? Because the null hypothesis here that the price paid is equal is rejected. Alright? And therefore, it can be interpreted that the price paid for last haircut by male and female respondents is significantly different. Now, who pays higher price? You have to look at mean rank. Okay? So, female 153.13 and male 72.43. So, naturally, female have paid more price for haircut. Naturally, so ज़्यादा hair होगा तो ज़्यादा पैसा लगेगा. All right. So this was Mann Whitney U test for us. Now, as I said, we can apply Kruskal-Wallis. Okay. Instead of say gender, if we use some other basis wherein more than 2 options were there, we can apply say siblings. Okay, number of siblings a person has. ज़्यादा siblings होंगे तो कम पैसा खर्च करेंगे ना, because the total money has to be divided in more number of people. Okay, let us see whether the siblings have any effect, and we will apply their Kruskal-Wallis test. Now, what is Kruskal-Wallis?